data science challenge. We'll go over regression and TensorFlow. So it looks like it's installed in utilities library. Porting 3 libraries we've commonly seen from utilities, importing star. So I think that's all libraries there. Train test split we've seen, sequential we've seen, dense and dropout seem new, early stopping, lambda callback are new. And this last part I have no idea what it's saying, but it looks like it might be checking for errors. So the data is loaded with these column names. CSV file is red. And then you normalize the data and convert the label value. So iLock is indexing. There's an equation here, df minus df mean with a standard deviation. Y mean, y standard is listed. And select features and train test split as well with the data. Model is created. It's a sequential model that's created with the dense output. And it's compiling this model. We've seen this before with the output shape and the param number. Total params is this. It looks like the total params and trainable params are the same. Model training is done with early stopping. There looks like there's 149 epochs. When there's validation loss, model is a general model. PU is model predict. The model fit is put on here as well. And it's basically going through all these epochs. There's plotting loss function here as well. And this is showing a lot of training loss. That's it for that one. Keras, LSTM is a pretty important common model used with Keras. So this consists of a set of recurrently connected blocks known as memory blocks. These blocks can be thought of as a differential version of memory chips in a digital computer. Each one contains one or more recurrently connected memory cells and 3 multiplicative units, the input, output, and forget gates. They provide continuous analogs of write, read, and reset operations for the calls or for the cells, and the net can only interact with cells via gates. So I don't know too much about this, but this is interesting. It installed live loss plot. Then their libraries are put in. Any new libraries here? Pre-processing sequence with pad sequence. This seems to be new. Tensorflow Keras utilities importing categorical, import train test split, import model and input, import LSTM, embedding and dense, import time distributed spatial dropout ID and bidirectional, and import model checkpoint early stopping, and then we have import plot losses callback. So you can load and explore the data here with unique words, read the file, fill in any null values, print any words that are unique in tags, and then list these. And then it looks like there's an end pad here. I've seen this command before somewhere in SQL. And you're retrieving sentences and tags, making a class with it. This is object-oriented programming, it looks like. Initializing the self data, having lambda looking for words, POS and tags, then grouping them. Looks like that's what it's doing down here. There's mappings with enumerate. What else is here that we can see? It's pretty long. Lots of different words it's going through and looping through. What's the order? Padding and train test split. MOS 50. Don't really know why it's doing these padding sequences for post values, but there's train test split. And it's building and compiling a bidirectional LSTM model. And then it has these input words with embedding, bidirectional models produced here, and then it's compiled. Loss is the mean square error. Optimizer is this ONM model. And then it's printing out all these parameters. Then it's training another model on 3 epochs, and then evaluating it. Search up what does LSTM do? Long short-term memory networks are a type of recurrent neural networks designed to handle sequential data and learn long-term dependencies. Traditional RNNs struggle with due to the vanishing gradient problem, okay? They do this by incorporating a cell state that can hold information over many steps along with gates that control the flow of information into and out of the cell state. There's learning long-term dependencies. Traditional RNNs can struggle to learn these. There's addressing the vanishing gradient problem using gates to control information flow, input gate, forget gate, and output gate. And there's applications. And looks like it's pretty much it. Let's see what Geeks for Geeks is saying. Introduction. Okay, working memory, long-term memory, different dependencies. LSTM architecture, working of LSTM, input gates, output gates, applications of also it's pretty useful. It's going to be used in language modeling, speech recognition, time series forecasting, anomaly detection, recommender systems, and video analysis. Then it's going into other reads for models. Yeah, it seems pretty useful. That's it for day 29. Thanks for listening.